Welcome to the Solutionology podcast. We're here today to talk about production using additive manufacturing and more specifically, understanding and managing risk. A lot of this conversation is centered around a PPAP process. PPAP stands for Production Part Approval Process. It's all about scaling the process for production launch.
So risk in production means something a little bit different for everyone. And on this podcast today, we're going to talk about what managing risks and being aligned on risks means as parts are going to some production state. That could be a clinical trial. It could be full-scale series production. It could be batch production where the part changes through each production cycle. But we'll talk about risks.
It's like additive manufacturing is a double-edged sword. And one edge is all about the benefits, the speed, and what you can accomplish with additive manufacturing, and the other side is the risk. And because of the first positive aspect of additive is we can move much faster, and we can take a digital file and get it straight into production. Because of the speed available, that in and of itself presents risks of missing key aspects of dimensional control, what's critical about the part. And then on top of that, we've got these other risks associated with the variability inherent in additive manufacturing. You could argue that there's greater variability in additive if you're not paying attention.
So when we're thinking about risk mitigation for our production projects, a key component of that is an alignment with our customers, collaborating with them to understand what are their expectations, or what does success and failure look like for them, and then doing the best that we can to incorporate a PPAP process to manage or mitigate those risks, keep them below the client's threshold.
PPAP stands for Production Part Approval Process. It's a common term that's used in many manufacturing verticals. It does have different flavors, so there's different ways to apply a PPAP process, and we've got our own. What does that look like for us?
It's about understanding the application, understanding the requirements, and then when possible, we want to do iterative steps as we're gearing up for production, so we can have samples and dimensional controls put in place as we both experience the product our client needs. We need to go through and we need to experience that running through our machines and seeing what the results are. We also need to provide them with samples so that they can see what the results are. And then as we're going through that, we're agreeing on what dimensional controls are the right ones for this. And as we add dimensional controls to it, it becomes more challenging to make, and often parts are dropping out quickly. So we want to agree on that dimensional aspect.
When we say dropping out quickly, you're talking about yield loss, about dropping out quickly and their scrap, right?
Yeah, it's a big consumption of resources as we're going to production.
Why even do a PPAP process, though? Everybody talks about additive. It's this magical thing that builds parts up from nothing. Why not just produce parts and expect them to come out the way you've designed them?
Well, the PPAP for us, we want to become familiar and experts at the products that we're making. If we have an order come in for 1,000 parts or 1,000 assemblies that we've never seen before, and we don't get a chance to experience it, become familiar with it, and put controls in place so that we can monitor that production. So as our client gets those 1,000 parts, they're providing us feedback. But if we haven't gone through the process of inspecting and going on that journey with them, it's like that feedback doesn't mean anything. If we're going to start dialing that in, we have to start over. Let's do a sample run. Let's do a dimensional inspection so that we can become highly familiar with the parts that you need.
But we've been doing additive manufacturing for a long time. Are there tolerances? Can we just apply standard tolerances? Why do we have to go through this dimensional process?
As a manufacturer who's making parts for others, you've sort of got to become aware of what's the actual manufacturing process you're using, what's the machine that you're running on, and the PPAP process allows that awareness to occur. And then we can get aligned with the customer and make sure that they may be calling for a nominal dimension that's plus or minus 0 plus 10 thousandths, for instance. But it's not like CNC machining where we can adjust the machine for that one part to hit that non-symmetrical tolerance. It's geometry based and it's build orient based. There's lots of variables that are specific to additive that other manufacturing processes don't experience.
So not only do we have to understand alignment with the project and client expectations, but we also have to understand the results of the printing method with those particular geometries. So it's like meshing all of those things, and that's done through the PPAP process.
Yeah. And the important thing for us is as soon as our team is aware that we're doing something that's going on the journey for a PPAP, we're going towards production, we're running samples, we're doing dimensional controls, we look at those parts quite a bit differently because we expect that we're going to see this part maybe in different versions in the future. And we need to make sure that we minimize the variation that we build into the processing so that we're reducing that possible end part variation at the end of the day. Are we orienting the parts the same way every time, even through rev changes? Are we managing where they're located in the build the same way? Are we packing those builds in similar approaches so that we're keeping the variables that we have control over, we're minimizing those as much as possible so we're seeing the least amount of variation on an output?
It makes me think of some of the programs that we've worked on where either we've developed the product in-house and manufactured it ourselves, or we've co-developed a product, so to speak, with a client. And the amount of iteration and collaboration, you mentioned collaboration early on in this discussion, how important that was to dial in both the design and the manufacturing process to achieve the desired results. And it's like when we're intentional about that and doing that on the front end, the back end is essentially seamless.
And we know what questions to ask. So as our team sees that coming through, we're already aware of the potential risks, so we're asking those questions. And then when we're delivering those parts, we know what the risk could be, so we can highlight those to the customer so that we can be as transparent as possible and make sure that we're accelerating through this phase without too many rework or restart operations.
That's one option. And the other option is some programs don't, whether it's perception or reality, don't have that time available on the front end. So it's like we've got the design finished and we just have to produce 500 of these parts. And then that's a scenario where you skip the PPAP process in the traditional sense and you just start producing parts, and then you measure the results on the back end. And in some cases you may have high scrap or high yield loss, and it's just a matter of learning in sort of the heat of battle rather than doing that proactively.
Yeah, so if each of our customers, they view resources differently. You've got time, you've got cash, and
time duration and cash seem to be the two biggest and often competing, whereas one sometimes wins over the other.
And those become hypercritical to how do we manage the PPAP. If we have a hard deadline like a clinical trial that we have to have functional parts for, but we're also making revisions from the previous clinical trial, we've got a window that we have to operate within. And to not do a PPAP there at all is sort of crazy because there's no chance to redo it. And it may mean that we have to highly accelerate a PPAP to verify that we're going to get the results we expect or acceptable results. And in those cases, we have to be highly aligned with our customers to make sure that when we take that risk with them, we're all aware of what the potential risk is. And it's the greatest chance of success to hit the deadline. Often in other cases, the deadline isn't so tight as that. It can extend on in a worst case scenario where, maybe cash isn't a problem. And we're going to gamble and we're going to hedge, our clients are willing to hedge the bets to have a chance at success with a high volume production, knowing that some of those parts may not be usable. They may need to reproduce it, but they're going to take those learning opportunity. They're going to make the adjustments, and they're going to, maybe the deadline for them changes a little bit, but they're willing to flex there. They just need to make as much progress as possible.
It's interesting as you share those examples and thinking about a program that we're supporting in real time today, where the resource limitation is design time resources. And so we're working on a program that is coming up to a clinical build. There isn't time to do the PPAP, but we've got reasonable, we have this reasonable assumption of what the results are going to be based off of the part design. And it's something like doing for us, 6-week production in a 3-week period. And since we haven't done the PPAP, what we're doing is that we're overproducing the critical parts, a certain assumption, a certain percentage that we've assumed on the front end so that we can manage risk in terms of time. So that's a case where dollars aren't as critical as time days. We're basically managing the risk by overproducing, which we can do in that time frame, and then have extra parts that we may not use, but at least we have enough to fulfill the needs. We haven't done the PPAP. We don't know what the results are going to be exactly, and we just have to overproduce versus going into it with full knowledge of the results.
And that scenario is even more complex because we've been producing similar parts in the past for several years now. So we're highly familiar with the parent part that's in the assembly. It's just a newer revision. We're going to be doing a little bit different operation to it, but we're building on that context. So it's the risk is managed the best we can. The client's aware of it, and this is the best thing that we can provide given the outcome. If this was a brand new client and this is the first time we interacted with them, the risk would be completely different.
There'd be much greater risk.
Yeah.
You said earlier it'd be crazy, and if money was no object, it's probably not crazy.
It's not crazy, yeah.
But if money is an object, then it is crazy. If money and time are both objects, then it's really crazy. But in some cases, there just is no other option. And it reminds me of a saying of, if you don't have time to do it right the first time, how are you going to have time to do it right the second time? And there are examples that we run into where there's this perception that there isn't enough time on the front end, but ultimately there's time traded because it is done again. That the parts are produced again because there wasn't the work done on the front end. So really when it comes down to it, our urge is to try and build that time in on the front end with a PPAP so that you can reduce the risk and the commotion on the back end.
And the easy way to look at that is if you've got a large scale assembly that you're making 50 or 100 assemblies, highly complex, lots of parts, maybe that total project is $100,000 or $200,000 for all those assemblies delivered. If you think about even 25% of those parts failing and reproducing, you got $25,000 in the initial loss, and then reproductions of another 20. So you have $50,000 that it could be net loss for that total rework there. If you said, well, let's spend $50,000 on the front end, worst case, let's do $50,000 invested on the PPAP, highly accelerated, small part production. Let's get our hands wrapped around it, and then let's go to it. Even if you go through that stage, if you're unaware of what the risks are, you come out the same at the end.
What's wild about what you just said, that would be the most extreme and probably not even real scenario. It's more like if you invested $500 or $5,000 on the front end for a PPAP, your return on investment is 10 to 100x.
Yeah.
Which is massive. The first initial production batch that's wasted, and then the second rush, it's a massive return on investment. And this is something that we push for regularly. Sometimes it's painful and sometimes it creates friction, but it's always done with the best interest of saving that amount that you said of preventing rework and preventing the time loss, because if you're redoing things. Those are things that we've experienced multiple times, and in the rush of doing it the first time too fast, you end up doing it again anyway. So we're always trying to push back on, look, let's make sure we're doing this methodically rather than just doing it as fast as possible.
The PPAP process may not always weed out 100% of all the things that we're going to experience, especially if we're going to large-scale production. There's always lessons learned as we go through PPAP process. If we're going to produce 5,000 parts or 10,000 parts a year for something, in that PPAP process, even if it includes 500 parts, as we scale up and we're going to ongoing production, sometimes we have to dial something in, but it tends to be less critical at that point, where it's not a showstopper, it's a optimization effort in that production cycle, and it just makes everyone's lives easier at that stage. It's not a complete rebuild, it's like a minor tweak or minor change.
So is every PPAP process exactly the same across all additive manufacturing methods?
Well, we try to correlate the right style of PPAP for the manufacturing process, the volumes in which we intend to produce, and the how dimensionally critical is the part. Because we don't want to overdo it. If we're making a part that's more ergonomic and the dimensional controls aren't so important, but the surface precision is, like the surface smoothness or the having roughness on the surface, we can't have that. That PPAP process is going to be tailored to that program. So we're going to take things out, or we're going to have just the bare minimum to get that PPAP process aligned for there. And on the other side, if it's high volume, highly dimensional critical, we're going to hone in on the areas that are really important, or we're going to discover and then hone in on it, depending on what phase we're at.
So it really is about understanding the risk at the first step, and that's what's the scope of the program, what's the manufacturing method, how many parts are going to be produced, which is under the scope, and then you manage that risk on the other side, which is building the program to support the scale and scope of that initiative.
Yeah. My hope is that when a client, new or existing, calls us up at DI Labs and talks to one of our team members, they're hearing things like, what are you going to use this for? What solution are you trying to solve with this part? What sort of things have you experienced in the past? Where do you expect to go with either this part or the program in the future? We can take that knowledge and be most effective with how we produce, making suggestions, and getting down this journey of getting this thing to production.
And we've got a PPAP process on our website, and this is what we use as the foundation for these programs. And then we shrink it or we build it out from there based off of the complexities and scope of the program. But we also live and have lived lives of product development and leading programs using other manufacturing methods. You shared an example with me this morning of a program you worked on. It'd be interesting to talk a little bit about that.
In a past life, I was designing a lot of sheet metal parts and having them laser cut. And there was a few holes that needed to be precise for the project we were working on. And as I was sending in parts, I wasn't having a whole lot of collaboration with our vendor, but I'd send those parts in, and I'd get those parts back, and I'd measure them. And there, with this feature that I have, this bearing isn't fitting into the hole. I recognized that there was an offset through all the parts in multiple orders where that, the way that they were laser cutting was producing a hole too small. So then I began modifying all my geometries to account for that offset. And then over time, something happened. Their machine was recalibrated, and now the new parts I was getting were way oversized. And I think that can happen, for nearly any manufacturing process. But it was sort of mind-blowing to me because I said, hey, I've been offsetting all my dimensions so that I had good quality outputs for me. I wasn't specifying them to be checked by your team, but I was just using this, I'm getting the results. Let me modify the design to get what I want. And they're like, whoa, that's, if you see that in the future, we just need to connect on that because, they should be coming out accurately. And we had to calibrate the machines. Now the dimensions are different, and sort of took a rework of everything to get back to normal. So if that happens with one vendor on one machine, of all the different manufacturers across the U.S. and globally, the machine calibration, the environment controls, all these things have such a big impact that without close collaboration, it's sort of being hopeful that you're going to get what you want.
What would you do if you could do that over again?
If I didn't have to learn that experience again, and I would have had that loop happen after I experienced it, I would have been more aware of the dimensions that I needed. I would have specified them. And then if I got results back on the parts that were different than expected, I'd reach out to them and say, this isn't what I was expecting. Is there something going on your end? Can we root cause analysis this with your team?
So you could have saved yourself some time and probably cost by communicating on the front end saying, hey, look, this isn't what I expected. Can we dial this in?
Yeah.
To me, there's two lessons. One is any manufacturing method is going to have some degree of variability. And two, without a feedback loop, bidirectional feedback loop, both sides, where you're setting expectations, you're understanding the expectations and then driving results to those. If you converge on a solution, that's going to be luck. It's not intentional. And so it's all about making sure that the manufacturer that you're working with, regardless of the process, there's clear communication on what's most critical so that the manufacturer can dial those things in. So we at DI Labs can dial those things in and then measure against them and drive to a converging solution rather than just getting whatever comes out.
Yeah.
It's also interesting thinking about that calibration fact that you shared, because that's just another piece of the internal puzzle that we face, all of us in the industry as manufacturers. We're running different pieces of equipment that have different baselines. So you could put the same exact part on different machines and especially across different methods and get different results, which again, that's where that communication is so critical, especially for customers that are working with multiple vendors. You can get different results, and according to the manufacturer, those different results are all within spec because of the manufacturing method that was used. So that communication is just critical. So for you out there that are using additive manufacturing, whether or not you're using it in-house doesn't matter, making sure that you're communicating what the critical dimensions are, what geometry and features are functionally critical. That's important to communicate back to the manufacturing team so that there's simply alignment. Thank you for sticking with us through this podcast. This is just a high-level overview, and it's not intended to capture all the nuances and specificities of each potential geometry and program. We're here as a resource to help answer questions and guide you through your production activities successfully.
Well, I think the important thing is that we really see ourselves as guides on the journey, and we're here to try to point out the obvious pitfalls. We want to help our clients avoid those.